All right, guys. So for a couple of days now, we've been talking about these different atomic theorists and all of these different things that they contributed over time to our understanding of what an atom is and what an atom is made up of. Okay. So some of you guys might have found this activity to be confusing because you were doing a lot of the research on your own. There was also some uh, he pretty heavy and kind of difficult to understand experimentation done, right? Um, but the big takeaways are not necessarily the experiments, but the outcome of those experiments. What did they discover? What did they contribute? So if you were getting hung up on the wrong thing in the past couple of days, today is really just to highlight the key takeaways that we're going to use from those people to better understand chemistry and better understand atoms. Okay, so we're going to start this off. The smallest particle of an element that retains the properties of an element. That is the definition of an atom. Okay, so if I have an atom of gold, I can have a single atom of gold and it will have the properties of gold. But if I try and take that atom and I split it into smaller parts, it's no longer going to be like gold anymore. It's going to act like something else entirely. So that's why the definition of an atom is the way it is. It's the smallest piece that you can break something into where it still has its original identity, essentially. So an atom is composed of three different subatomic particles, and subatomic just means smaller than an atom. Okay, and you should have learned about these or picked up on them when you were researching your theorists. So we have positively charged protons. We have negatively charged, not neutrons, electrons. Just because protons starts with a P like positive doesn't mean that happens with electrons. And then neutrally charged neutrons, that's where that comes in. I just spelled neutrons wrong. Whoops. That's what I get for writing and talking at the same time. Okay, so two of those things are located in the nucleus of an atom. So think back to what we learned about the center of the atom, where the nucleus is. We learned that the protons and the neutrons were there at the center of our atom in the nucleus, while the electrons are located outside of the nucleus in what we call orbitals. Okay, so if you remember Bohr's model of the atom, it had the electrons in that like those planetary orbits outside, kind of circling the way that the planets do around the sun. And then we've got this nice little chart right here, and all it's going to do is help summarize what we've got going on. Okay, so protons, we just talked about it, they're positively charged. So we consider protons to have a relative charge of +1. When you think of protons, you should think of +1 charge. Neutrons are neutral. So are they going to have a charge? No, they're not. So they're just going to have a 0 charge. Now electrons, they are negatively charged particles. So if protons were a relative +1, electrons are going to be a relative -1. Protons and electrons have pretty much the same charge, so if you have a proton and you have an electron, their charges will cancel out and make it neutral. So sometimes you're going to be asked to draw a picture of an atom, just kind of show where the protons, neutrons, and electrons all go inside of it. And if I were to ask you to do that, we would draw a proton like this. We would put a plus sign because it's positively charged, and then just put it inside a little circle. So that tells us positively charged particle protons. Neutrons, typically you would just draw a regular particle with nothing inside of it because it does not have a charge. And then for electrons, you of course would do it as a negative, okay? So like a little tiny negative circular particle. Then we can kind of rehash their location. So we know that protons are located in what vocab word? The nucleus, along with what other particle? The neutrons. Nucleus, neutrons, kind of sounds the same, kind of go together. And then the electrons, of course, are on the outside in what we call those orbitals. Now the mass is a little bit more tricky, okay? What we're going to write down right here is pretty much just like a relative mass, just to kind of show what has mass and what does not. So a proton, we say, has a mass of 1. They're pretty big, so they're pretty heavy, at least compared to other things. Neutrons are also a 1, so they have almost the exact same mass as a proton. Are they exactly the same? No. And that's why it's got this little asterisk right here, because a proton is not exactly 1, and you're thinking to me, well, Miss Potter, we're all about units, and here 1 what? Well, you don't have to worry about that right now. We're going to get to that a little bit later, okay? So just know that protons have a mass of 1, neutrons have a mass of 1, but electrons, we say, have a mass of 0. Now, electrons are matter, right? So by definition, it has mass, and that's absolutely true. It has mass. They are just so tiny in comparison to the protons and the neutrons that if we call protons and neutrons 1, it's essentially 0 for our electrons. Okay, that's just how tiny they are in comparison to the protons and neutrons in general. So is it really 0? No, but do we pretend that it is? Yes. And is it mathematically okay in the end? Yes. Okay. So recognize that this is not like 100% perfect in terms of talking about mass, but it gets the job done. Okay. I hope that makes sense. So moving down now, when you look at a periodic table, which I will link a periodic table for you guys if you haven't opened it up already. No matter which periodic table you look at, whether you look at the one that's in our textbook or when we return to school, the one that's on our wall in the classroom, or the ones that you Google on the internet, they'll all be slightly different, but there will be the same information on all of them for the most part. So just as an example, information that you should be able to find on every periodic table and every little square, I guess, for each element, you should be able to find the name of the element. You should be able to find the symbol of the element. And you guys have gotten lucky so far because we haven't had any element and ion quizzes, because that's kind of difficult to do virtually. But we are at some point this year when we come back going to be tasked with memorizing the symbols for some elements and some ions. So instead of writing hydrogen, we'll just write H, just kind of like an H2O. We don't write hydrogen, hydrogen, oxygen, right? We do H2O. And then this number right here, this 1, is called the atomic number. And the formal definition of that is yet to come. This last number down here, and this number will always usually be some sort of decimal, okay? And that's how you distinguish between the atomic number and this number, and it's called the atomic mass, okay? So that number, the 1.0078, is our atomic mass.